Okay, so it's 9:05, and we're supposed to be starting the lecture. Again, good morning and welcome to the subject. Welcome to the university. I've got a message from students. Yes, everything will be recorded. I will start recording soon. Yeah, all subjects, and I think I'm not sure which class you're talking about, because some classes will be removed. And so can you, student who was messaging me, Ahmed, can you confirm which subject you're talking about? Yes, Ahmed, which subject you are referring to? Yes, that's right. Yeah, so AWM, it is asynchronous subject, so the lectures are recorded and the 1 hour slots can be consultation, which your subject coordinator can talk to you about. ERM, we're working on it, so most likely it's going to be moved. And again, you will be advised about this. Yeah, that's right. That's right. So that one, most likely it can be removed to 11 a.m. ERM to be moved to 11 a.m. So you won't have that clash. Okay, so we have most of you with us this morning. And is this your second year or your second semester, or you are new student? So who is, can people raise their hand if they are in their second, like if they've been with us before, like they already attended before? I just want to see how many of you, but it doesn't matter. You know how to raise your hands? Just click on the raise. Okay, so we do have a group of students who've been with us, and some also decent group who are not, who just started. Okay, so some of you have just started. All right, thank you for that. You can take your, put your hands down. So yeah, today we will be talking about the subject, how it's really gonna be running, and also I will, with the lecture notes, which you are seeing the first slide. So just before I talk, yeah, ideally I'm gonna be recorded. Let me start recording, and recording will. It's actually, the recording is on already, so maybe it was automatically recorded. So the recording is on, already recording, and we should be fine. Yeah, Muhammad started the recording. Yeah, students can do it, and I typically would do it before. Yeah, no, well done, Ahmed, thank you. So yeah, but typically I do that when I start talking about the topics, no problem. So, right, let's talk about, let's start with the slides, because the slides will take us through the the way the subject will run and how things going to be going. So as we go through the slides, I will be sharing the LMS. And given that some of you have just started, they may not know about LMS. LMS refers to the Learning Management System. And that's what students use to interfere with their lecture notes, with meetings, and I think it's used in many other institutions as well. So yeah, the key learning element for this subject and most, I think all your other subjects is the LMS. That's where your lecture notes are, the recording are, the softwares you're going to be using to have access to them. It's all going to come through LMS. Right. I just need to accept some students because they're not using their student's ID. Yeah, no problems. So this week will be basically an introduction, the slides which you are seeing. Guys, in case if you're not hearing me or you always try to unmute yourself and talk or send me a message. I think most of you do this very well. In case communication or connection is lost, just wait. Just stay where you are in the same channel or the same subject, and I will be back somehow. So I will find a way. In case there is an earthquake and disaster happened, I will also try to find some other way. So if you lose me for whatever case, in case communication goes down, don't think that the lecture is cancelled. Okay. And please ask as much as you want to do these. Put it this way, this subject I'm teaching at master level, so I really feel that I'm working with the junior engineers who are practicing. I'm a structural engineer by practice as well, a practicing structural engineer, and I do enjoy teaching authentic engineering applications rather than just not only just theories for you to memorize and know and goodbye. No, I'll be showing you how, at the end of the day, we make money from these skills. This subject here, designed for structural dynamics, definitely it will be one of the skills engineers do use in the outside world, and it's mainly used by structural engineers. I know maybe part of like a group of you have been practicing in their home countries or whatever, and you know there is a specialty called structural engineering. It's one of the disciplines practiced in civil engineering. So there's civil engineering. Civil engineering got many different roles. One of their main roles is structural design. So structural engineers, what they do, after the architect shape up the building, put how it looks, put the dimensions, put different features, the structural engineers will take those drawings as well as other servicing drawings and design the skeleton, the frame, whether it's concrete, whether it's steel, whether it's timber. And yeah, he will be designing like columns, footings, beams, shear walls, etc., etc. And one of the main skills engineers require is to understand the dynamics behavior. And it's a requirement to do such check. And we will talk about this a lot. In this subject, you will be working on a real, very, very close to real project. So it's kind of you are actually working with in an office. You're going to be working with a group. It should be really an engaging subjects, not only theories. Yes, there are theories because they're going to build their in-depth learning. And I will be talking about where you're going to be assessed for the theories and where and how you will be assessed for the practical work. I will come to this later. To pass this subject or to get the most out of it, to get that skill and put it in your closet, you know, put it in your toolbox. Let me say toolbox. I look like as it's all about filling your toolbox with skills. To put these skills inside your toolbox, You simply just need to attend the lectures or carefully look at the records, right? Coming to the lectures is more useful because you can straight away ask the question. You will have that momentum to ask the question rather than just waiting or sending email. So yes, you're more than welcome to look at videos. That's number one. Number two, come to the workshops. They are face-to-face. I know we are calling them to be blended. And as per what I'm going to tell you, it's going to be alternative. So 1 week going to be face-to-face in Bendigo. Then the next week going to be face-to-face in Bandura or Melbourne. And I will clarify this further shortly. Come to the campus when you are required to. It's like attending meetings on site. All right, because put it this way, recording won't be happening for workshops. When you are required to, only if you're supposed to do it online. So when you are asked to come on campus, you won't have access to its record. And things will be clarified further later. So these are the two key success. Yeah, you need to attend, you need to go through the material. Is not complicated. It's really straightforward. There are theories, yes, from next week, or actually the week after, from week 3. Let me make it clear. This week is introduction, just telling you how things gonna move. Next week, I will introduce you to commercial software, okay, which gonna let you practice that structural design case study with your team, because your assignments, you're going to be 50% of your mark going to come from a group work assignments, which we will talk about. And that will be basically based on practice. Students like it a lot. Students do very well. I feel a group of students, they really practicing like engineers. And I'm sure those people can put what they did on their CVs, resumes, and market themselves very well. And in a few months, or if they like to do this kind of work, they will find their way there. The other 50% is coming from theories, which you need to understand. I'm not asking you to memorize from now. You need to understand. And some of them starting from what you studied at university. So, you know, vibrations and periodic analysis. So some people may find difficulty. I don't want to say it's difficult. It's just because you need to study. You need to spend those required hours every week. You know, don't bypass or don't delay learning what we studied. And those theories we will start talking about them from week 3. So as I said, this week is just introduction. Week 2, our lecture going to be about introducing a software. Then week 3, we will start those theories. Now the theories, they're going to underpin or prepare you to learn the practical work we're doing during the workshop. So mostly during the workshop, we're going to work as a real engineers in designing a building against earthquakes and wind loads. Okay, that's during the workshops. But I should also say during the workshops, we're going to spend half of that on solving some problems related to the theories we talk about during the lectures. Okay. 2 people are raising their hands. Do they have questions? Sandish, or that was just before, and Ahmed. You have questions, or you want to take your hands down? Okay, so no questions. All right, so that's all. These are the two key learning elements. Okay, and typically people doing very well with the subjects, they go out with those skills, local skills, which you definitely can use. Maybe next year, maybe another 5 years. You know, in civil engineering, what people like about it, like the civil engineering community, it's you can spend your life in different jobs depends on what you really start liking. So people spend maybe 3 years with construction company practicing as a construction engineer, Maybe they spend another 3 years on drainage design with the council, or environmental studies related to civil engineering. Some other, that's with council, that's what they do mostly, plus other jobs. And some other peoples may divert to structural engineering after 8 years, and you definitely need to have that background. So there is dynamic in this firm, which is really kind of good to have. Maybe after 10 years, when you get into your 30s or mid 30s, you will start, you want to be stable, and maybe then you want to decide on something else. So definitely you are young and you can go through different disciplines in civil engineering, but this one, structural design, this topic is definitely one of the core skills you can have a practice on. So this table or this slide, simply it's showing you what we will be studying as the topic of your theories. As I said to you, the lectures will be mainly, which is 2 hours a week online. I will be talking to you about theories. That's from, as I said, week 3 all the way to week 11. This week and next week, it will be an introduction for this week. Next week, we'll be introducing you to reinforced concrete building software, right? We will talk about modeling, what computer modeling is about, and then I will get you focused onto the software we're using. And that software, you will be using it in your real, authentic practice. Okay, we will talk more and more about it, and we're going to be applying it and implementing it during your workshops later during the semester. So I just want to hand it to you in terms of skills, and then I will be touching base on it again and again. Now, from week 3, we will start the theories. The theories, as I said, they will underpin, in part, some of your skills required to work on your real projects. That's one thing. Another thing, it will definitely prepare you to practice engineering applications outside. Now, the good thing with this subject as well, it's not only teaching you about buildings. Structural engineers can be also asked to evaluate the performance for, rail guards in the highways. On the highways, they got the, let me just do a search and show you what I'm talking about, which is what I'm trying to say is we're going to be, those dynamic skills are not only for buildings, they are also required for there's a problem with my keyboard, unfortunately. It also can be used for other type of engineering problems, which is for example, you're going to be finding the stability for the rail guards where you need to stabilize it. There is some odd issue with my keyboard. It's not typing. Yeah, okay, that's good. I don't know. Maybe I need to restart, but I have no time to restart. I may do it during our break. There is something. I sensed it before I started the lecture, but I didn't want to restart. I sensed there is a problem with IT technology, but it's just not typing. Anyway, look, I will show it to you. What I'm trying to mention to you there. For example, I think you all drive cars, yeah, and you have that speed bump. You see many roads, they put those speed bump, right? So why are they putting them? Can someone tell me why they putting the speed bumps in the street? Those annoying speed bumps when you're traveling at 60 k's per hour. Can someone tell me why they put these things? Why they put the speed bumps? You know what speed bumps are? Just unmute and talk. To control speed, excellent. Yeah, guys, feel free to really talk. It's going to be more engaging. Yeah, that's totally right. And avoid accidents. Excellent. So that curvature and the height in function of the speed, right, are designed. So, you know, the speed bump they construct in the roads, the height of that, it's like you're gonna see it's like based on a sine wave or a cosine wave, sine wave. And from math, you've all studied trigonometries. You got the sine, and the height is really designed in a way where it gonna, if the
Sir, you have muted.
when did that happen? Okay, no problem. So what I was talking about, I believe you answered my question, so you know about the speed bump. So yes, your answers are correct to control speed, but who really designed and confirmed such profile or arrangement can come all the way down to engineers who knows about dynamics, because it depends on the speed and what the council and or Vic Roads want to limit that speed down to. So for example, if the speed bump requires drivers to drive with or up to 40 or 30 k's, then if then that means in case that negligent driver goes above this value, they will get an impulse or shock or acceleration, right? That can harm his car. And then, you know, again, engineers should not really do it aggressively where the car may lose control. So all that is kind of part of, we're going to have examples and topics that will teach you this. That's what I'm trying to say. Again, this is all started when I was telling you this subject won't only be teaching you about buildings, it will also be teaching you skills that will let you understand how to control, for example, traffic in roads, which is going to come down to dynamic skills. And I think that when I was talking to you about, they are under this week, you're going to see them. You may be working as a council engineer, and council will be asking typically to check the health and performance of existing heritage building. Heritage buildings, they are those historic buildings that council don't want to get rid of, but every 6 months or after events, after heavy wind load, after an earthquake, which we had like several months ago, they send engineers to write a report. Then there are methods for the engineers to test those structures. Those methods, you will be taught about them in this subject. So the theories I was talking about, they again, not only for you to memorize and know about and good luck, no, they're going to be asking you to do a real engineering practice. And again, if you work with me every week, you will be successful towards the end. If you're going to ignore the topics and say, because let me put it this way, you will not be assessed. You will not be assessed about those topics until the final exam. Those theories I'm talking about and the examples we're going to practice and the workshop questions we're going to practice from week 3 all the way to week 11, you will not be assessed about them as a test or exam until your final exam. However, some of the skills that will be learned from here will be used in your real, authentic projects. You're going to be submitting for assessment 1 and 2 in a group. So you need to get them right to have a correct submission for your assignments. And also, it's not good. I do have a failing students who are gonna not study things very well until the exam, and then it's gonna be a lot of load on your on you to really learn all those skills in 1 or 2 weeks. It's not enough. You should really make sure every week we study it together. You know about it. You don't need to memorize equations at all. You just need to know what does it mean in details, what practically it means. There are some really in-depth theories, which I will be very clear in telling you, you don't need to worry about this. I will be very clear. I will tell you this is just for you to know from where it's coming. But at the end of the day, there is this simplified equation. That's what the engineers use to evaluate, for example, that profile and curvature of the speed bump. So you're going to say, as I said, one of the things you need to report is the height of the speed bump to control. All right, it's not randomly done, just some asphalt, you put it upside down. No, it needs to be controlled. Yeah, that's kind of our teaching topics. I think you all know that we do have lectures for the subject and workshops. The lecture is going to be 9 a.m. to 11 a.m. They will be recorded, like what we're doing now. And as I said a few times, this week and next week, they are general. This week introduction, next week introducing commercial software that you will partially use for submitting your first major assignment, which we will start next week. Maybe tomorrow we talk about it, or sorry, I mean during the workshop, we will talk about it just as a start, and that's it. Now, during the lectures, there will be time to solve walked examples related to the skills or topics we're talking about. Like, for example, from week 3 to 11, we have those skills, theoretical skills we're talking about. There will be always examples to solve to make sure you know what those parameters are. And we should have about 40 minutes or 1 hour to talk about those parameters and skills. Yeah, so that's all about the lectures. They will be online and recorded. The workshops, they are blended, and the way we're running them is over an alternate method. What does it mean? We do have a group of students in Melbourne, Bandura, and we do have a group of students in Bendigo. Now, 1 week, it's going to be mixed between face-to-face and online. The main aim of that is for the students to live that real-world design environment. So when I won't be coming face-to-face to solve things for you, I will be during the workshops, just to clarify, about 50% of the time will be going to solving more worked examples, right? Now, some of them we may not need to have a lot of time because we did most of them during the lectures, but some will be really, that's I'm talking about this part here, solving workshop examples. They're going to be similar to the examples we solved or started solving in the lectures, but we will have more. All right, maybe sometimes I leave the students to practice on them, right? Because I want them to, from the skills they developed here, they can go away. The good news, guys, are like, you're always gonna have the solutions for them. But I'm saying this again, don't always assume the solutions are there and you're gonna say, I'm gonna study them 2 weeks from the final exam and I will. No, there is a lot of things, and from student feedback we receive every year, they really like to have the examples, and some of those solutions I did not solve all the steps. I left part of them by the students to solve. So you need to really do them week by week. That's the best approach. They won't take a lot of time from you. Really, you know, ideally each subject should require you 10 hours. You're spending 4 or 5 hours with us. Yeah, so 2 hours lectures, 2 hours workshops, plus questions or whatever, say 5 hours. The other 5 hours you're supposed to be spending them at home for the subject. And I'm sure you should be able to find those other 5 hours. Okay, and the 4 or 5 hours are more than enough to really go over what we're asking you to do. So that was 50% of the workshop. The other 50% is going to be giving you hints and support to work on your assignments. So we will start our assignment from next week, or maybe even this week during the workshop. I will introduce you this workshop. So after tomorrow, we're going to have our first workshop. It will be face-to-face in Bandura, Melbourne, and it will be online for Bendigo students. So I'm asking you, and I did say that to you yesterday with my message, with my welcoming message. And also, if you want to know where you can know about this, I will just share with you the LMS. I'm just bringing it on screen. This is your LMS page, which looks like this, or let me put it in the way that the student is seeing it. This is how you are seeing your LMS page. All right. I did strongly suggest you over like a few days ago, I've sent you a message to look at Start Here. And there is a section for which summarizes the assessments. But in this folder here, or this tab, you're going to have more and more details about them, which I will always talk to you about it. So we will talk about this later on. So this link shows you from where you're going to submit your assessments. Right, now from here, from this tab, so the way it works, you can see there are those sections or grids. First grid, I suggest you to scan through it to know about the intended learning outcomes. So it tells you, which I've kind of already mentioned to you earlier, just this morning. And it's also talking to you about, so intended learning outcomes. You're going to develop well understanding for measuring dynamic properties. Again, as I said to you, it's going to be in an authentic approach where you're going to know how things are really used outside, not only theories. We won't be using theories and just applying those theories and that's it. You're going to sense, or you should sense, the real application for it. Number two, you're going to be developing strategies about the modeling, computer modeling. That will be another main part we're doing. And as I said, from next week, we're going to introduce you to those packages and software, which should be a big part of your first assignment that you're going to submit. And it's going to be an excellent tool you put on your CVs or for your recorded skills. Apply finite element modeling. Yes, we will do this while we use that software. Undertake independent checks. Yes, now, as I said to you, we're going to be in group working on real projects. In parallel with that, we will ask you to use softwares, and also we will ask you to do hand checks and compare. So while you're going to be modeling that building with a software, you're going to be also checking the outcomes. They may not be same, they may be different. So you need to report the reasoning behind all that. Okay. So these are the intended learning outcomes, which each subject in your course should have such learning outcomes. This section is talking to you about the assignment or assessments. Assignment one, as I said, this will be about the building, the 10-story building. Group students in groups will be working on such assignment. This assignment will go for about 5-6 weeks, and part of it will be doing hand calculations over several sections. And as I will be talking to you during the workshop, I will be asking the students not to do the submission in one go. You're going to be doing the submissions over stages. So for next week, you have a submission to do. All right, I did over the years, I find students gonna be learning better if they're gonna be supervised from my end. And I will be asking the students or the groups to be submitting their work every week. I will not mark it, but I will look at it, and maybe when I come and see you face to face, I will give you some kind of what's missing, because I don't want you guys to wait until weeks 5 or 6 or whenever you need to submit it, and then you have gone totally the wrong way, right? And you will lose them, because sometimes maybe you know the engineering side, but you don't know how to represent it. The calculation reports, guys, is one of the main components that's part of the project's documentation, which you're going to be paid for. They need to be correct. They need to be systematically presented. So I want you to work on all doing this in an well professional way, not only just, you know, like what maybe you've been doing, just solving a question and sending it back as one sheet. And no, you need to be presented in a proper way, systematically. You're going to be first thing with that building, you're going to work like from this week, from the workshop, I'm going to show you how to calculate dead loads, live loads over the 10 stories. Then you need to work out, I will let you actually use 2 different softwares. It's like what an engineer is doing outside. Okay, and then how you put the documents together, because you know those, like in a project like this, those documents cannot be endorsed or stamped until another maybe 1 or 2 engineers checks it from a different firm. So your reports will be going to another engineer, and if it was not done in the right way, it can be rejected. If it's rejected, your client gonna be really stressed out, because it's all money. You can't give your calculation report to another engineer to check it, and then it's all messy, it's not making sense, it's even not presented well, because they won't bother. They will look at it for 20 days, and they will say, you know, their comments won't be about your engineering outcomes. They will just say it's not clear, it's missing, it's not, where is this, where is that? And the other engineers will do that because they're going to get paid for the hours they're spending. And you just hear costing extra monies for your client. This is how they look at it. So you have to do your reports in a proper way. And guys, remember, you're now a group. So I would expect it to be in a high quality order. And I will be talking about this. As I said, half of your workshops going to be allocated typically for talking about your assignments. And yeah, always when we meet during the face-to-face time, okay, talk to me about it, show me your work, because organization skills are required beside the engineering skills, and the calculations needs to be correct. So that's about assignment 1. Assignment 2, it's another authentic application, which we will start maybe after maybe week 7 or 8. We're going to see the schedule later on. You will know about it. Another 20% from that. As I said, these are partially related to the skills we teach you over the weeks, partially. And some of the skills you're just gonna know, because it's kind of real world skills that you can't get from textbooks. That's what you're gonna get from working and asking, and I will be giving you guidance there. Number 3, it is the final exam, which is coming from the theories. Okay, and it will, if you're gonna study and understand the workshop examples and the worked examples we do during the lectures, I can tell you you're gonna be fully prepared for the final exam. It is never enough to study those examples before the exam straight away. You should know them week by week. Is there a question about intended learning outcomes or subject assignments? just unmute and ask, or you're more than welcome to. Okay, yeah, I'm actually seeing some. Sorry, sometimes you're actually right, and I miss it. So if I miss it, just unmute and tell me. Yeah, the volume is up. So I'm looking to your messages. Okay, now I will, Nadim ask the question if this week's workshop online or face-to-face. I will show you a schedule. So the short answer is Bandura students face-to-face. So Nadim, from where are you? Where are you based on? Melbourne or Bendigo? If you are a Melbourne student, yes, gonna be face-to-face. Wednesday, your workshop gonna be face-to-face. Then the following week will be online. Okay, so where is this all, as I said to you in my message? So after we finish this section, let me just, before I go there, let me read the question and then I read the other questions. How are we supposed to be? Yes, I will guide you through that. They're gonna be kind of a software, not a software, it's like an app I'm gonna be putting on LMS. And during your workshop, Wednesday after tomorrow, that little app, they're gonna be something you do over the LMS, and you will be all grouped accordingly. Okay, it's up to you. So I'm gonna be putting kind of group. I will make a decision whether per 5 or per 4 students, and then you will be like they're gonna be zones with 4 locations inside them, and you just need to jump into those groups, and then you're gonna form up your group and suggest you to beat each other. I trust Bendigo students. I think we have small group there. They can be grouped as one. But again, I will talk about how we're going to communicate and do that later on. So these are the only 2 questions I have so far. Let's continue with our LMS. This textbook, it is recommended, right? And all the examples, workshop examples, which I've already given you the solution for, are basically built from that textbook. It's very good book to have in your library when you're going to be working in such areas. So it is recommended, but all the teaching materials can basically be coming from what we shared with you from this from the lecture notes and the workshop questions and the booked examples questions. Right, what's required for you to develop and move on with your learning? You're gonna need, beside the lecture notes and all what we are giving you in the, and what we are giving you during your workshops and lectures, you're gonna need to have access to the standards, to the local standards. Now it can be accessed from here. So basically our undergraduate students, they actually also have access and also registered. This link here, you need to register. Look, it's up to you. It's good to be registered as students and have access to it. But I think because you're working in groups, maybe 1 or 2 students can do it and it's enough, because I just want students, beside the skills they're learning for the dynamic design, I also want them to see how engineers actually look at the standards and pick values. So for example, to find the dead weight, to find the vertical loads on the buildings. As you know, vertical loads are coming from dead loads and live loads. And as you studied before, to find the ultimate load, we have to use factors. We have to multiply dead load by 1.2 and live load by 1.5. Who tells us this? It's not up to me or up to whoever. It's up to the standards. So the standards which tells us about these factors, for example, is this one. So I will let you kind of have an exposure to it. So in the future or when you work, you know about it. And there is many other things to use from the standards as well. This one here, it does help us to also impose and permanent, life loads, same thing. Who tells us in hospitals we use 5 kPa? kPa is kilopascal per meter square. And 1 kPa is equivalent to 100 kilograms per meter square, right? And we'll talk about this slowly as well. So who tells us, like, in houses, residential, engineers need to assume there is 150 kilograms per meter square or 1.5 kPa. In hospitals, can be 5, can be 4. Who tells us this? Is Mr. Standard. It's not up to us. Earthquake, you're going to be working with this slowly in details. So this one, yeah, is really important. And for the subject, how to download it is from this website. And as a student, you are able to have it for free. But to get into those, read the instructions and ask me, because you need to register. You need to download some of this because your Acrobat cannot read the files until you download special security file. Okay, so just go through the steps and you should be good. Any questions, we always can solve them. All right, so right, so I trust you are on top of all those sections. Now start here, it's gonna give you more details about your the subjects. One of the main documents you're gonna have for each subject you're studying for your course, it is the subject learning guide, which is most of the information you have inside there, they are actually available on your LMS. Okay, most of what we have on this document, they are already available on your LMS. Like these ones here, silos or the subject and deadline outcomes. I've already introduced them to you before, just in the previous slide. I think one of the main thing, take your time to scan through them. Using LMS, I believe, make sure you know how to use it. There are some instructions here. And come to me and ask when you need anything. Section 3 here, learning and assessments. This is the schedule I was talking about. This one will tell you what we're going to be doing in each week. Week number 1, which is this week, we have an online lecture, a workshop, Bendigo online, and Bandura on campus. Yeah, I trust this is really clear for you. So answering the question I had from Nadim, Bandura students on campus. And it's simply just going to be alternate. So week 2, it's going to be online for Bandura students. And Bendigo going to be, we're going to be in Bendigo. It's just this going to give an equivalent experience. And as I said, the authentic assignment is going to be very useful for you to interact with me, because I will not be dealing as your teaching staff. I will be also dealing as your client, as the architect or builder who wants to get the drawings from you. Now, for the first assignment, beside the reports and calculations and all those things you're going to learn, you have to make drawings for the builder to build that core. All right. We'll talk about this in the next 2 days. So I will be interacting face to face with both of you over the weeks. So this is really how we plan. Now, this information is also available on that PDF I was talking to you about, which is up to you. Want to read it from there, from here, it really doesn't matter. So this PDF, the subject learning guide, also shows that table, which is a learning and assessment schedule. All right. Do you have any questions about this table? Now, how I'm going to be organizing the online delivery. So Wednesday, when I'm going to be on campus, there's going to be special channel for Bendigo students to enter from. Bendigo students, are you able to confirm? Are you with me now? Let me check and see. So just raise your hands. Yeah, okay, so I know I have small group. I think, yeah, I'm seeing you. No, that's perfect. Okay, no, all good, thank you. That's fine. So when it's your turn to be online for the workshop, I think now you're seeing you are able to, you will have a link, and that link will be only accessible, I will say it clearly for you, Bandura students. When we're supposed to have face-to-face in Melbourne, students in Melbourne supposed to be coming to work with their colleagues on the projects, okay? I won't be taking, yeah, so you need to work because that may impact your contribution to the assignment and may reduce your marks. All right, I won't be taking or recording the attendance, but you may not really have, you may not end up making the contribution required. So I'm assuming face-to-face means students are coming to their group and working together, to their groups and working together. Now, this week, for example, week 1, it will be face-to-face in Bandura, and Bendigo students will be attending online. And how they're gonna, they have special link. I will show it now to you and also send it to you guys before we start the workshop. So if you go to your teams, right, you have maybe less teams than what I'm seeing here because I have different subjects. So this is your teams, and Bendigo students, then they're gonna see this kind of grid, and that's this one here. It's online. That was your lecture, which I've invited all the students to come to. That's the lecture. This is for the workshop, but it's only for Bendigo. So only the students we have for Bendigo students are able to access this link and are able to find its recording, because I will be recording as well the workshops for the students who are meant to be online, right? So this is really how it's gonna run, and same thing will happen for Bandura students when I'm gonna be in Bendigo in week 2. Bandura students can be working online, right? And we will, when we meet, it's really up to you guys if you want to create your own groups and work together on the project during that. And I'm sure you may need to do it to talk together later on. It's really up to you. I leave it. But you can always come to campus and use the rooms that, the rooms where we're gonna meet. You always can use it during that time. Just go there and communicate with me, because basically during the workshops, as I said, we're gonna spend 50% of it giving you more solutions to do, whether I do it in part, you do the other part, but the rest we will be giving you guidance as required on your assignments. All right, so let me go back to the sheet. Is there any questions? Do we have any questions about the arrangements for your, let me check your questions. Some students are raising their hands. If that was just before, that's fine. Is there any questions about the delivery for the subjects? Are you all okay with it? Clear, comfortable? No, today there's no workshop. Who told you there's a workshop today? You never had a workshop today for this subject. Dynamics workshops, this subject's workshops, they are on Wednesday, always. Today there is only a lecture. Okay. So the lectures are today from 9 a.m. to 11 a.m. and the workshops are Wednesdays. Yeah, do you know what was the time? Can someone confirm what's the time, Wednesdays?
It's 10 a.m. to 12 p.m.
Excellent, thank you. So 10 to 12, yeah. And yeah, that's always, so it's gonna be either face-to-face, you need to be on campus and work with me and with your teammates, or it may be online. So 1 week face-to-face and 1 week online. This week we're starting Bandura to be face-to-face, Bendigo online. Then it's gonna change over the semester where week 2 gonna be Bendigo face-to-face and Bandura online up to the end of up to week 11. Then week 12, again, everything will be online because it's just giving you guidance about the final exam mostly. Is there any question about this? All right, so if we're all good, it looks like
Sorry,
yes, come in.
yeah.
Yes.
I missed the initial 5 minutes of this lecture, and I'm not sure if this has been spoken about. We have a clash with schedule for this subject and advanced water technology. So we have that lecture at 8 a.m. and this one at 9 a.m. So is there anything that we can do about that?
Now I talked, yeah, this subject, the not sure, have you been attending that lecture so far or not yet?
I've been attending that. It's pre-recorded, so I missed the 5 minutes in here, but it's pre-recorded. Yes,
It is pre-recorded, and the lectures, just the naming of it, the lectures, they are consultation time. So group of students who are having this class, they can always attend their consultation from 8 to 9. So that subject, advanced water management, it's meant to be watching the records prior to the lecture. Then you just attend for consultation. Like if you go over the lecture, you have questions, you need some support in solving some of the problems you have there, you can attend the first half and get an answer for, yeah. Did you talk with Gokhan about this, the subject coordinator?
Oh no, sir. I wanted to check
Not
with
yet, yeah,
you.
because that's how that subject is designed. If there's any issues with that, let us know, but we understand it's typically workable because this subject, we just the staff wanted to know, to let the students know there is a consultation time rather than just making it open for the students to make their own appointments.
Understood. Thank you, sir.
No problems. And as I said, for the other subject, we're working on it to remove that clash. Let me see if there were other questions. No, I'm seeing there are 3 hands raised. I will assume, yeah, I answered you guys, and I will take them down. But if you have any questions, always jump in and ask. All right, so look, let's let's have a quick break in case you want to drink something or have a rest. Usually I give up to 5 minutes, but let's up to 10 minutes actually I give, but for today let's have 5 minutes. So from here, I can then just talk about the topics, right? I will be talking about the topics that we will be covering, but yeah, it won't be in detail. It's just for you to know about them for now. All right, so let's have a quick break and we'll meet back in 10 past 10 a.m. You can stay online here, but I will just unmute myself and come back in 5 minutes. See you guys. Hello again. Let's back to this, and yeah, we can continue from here the topics. No questions anymore, so we can keep going. Yeah, we stopped at this slide. And again, this is just a repeated information about your assignments and your 2 assignments and exam. These assignments, yeah, I think this is actually should be updated. It's a group. This one is actually a group assignments. Yeah, one of them was partially, that's why it says individual. However, I will be talking to you about this. Your assignments will require you to name which students did what. All right. So as you go through the reports or solutions, for example, if I go to the earthquake or the building assignment 1, they're going to be parts about wind load, parts about dead loads, parts about earthquake loads, parts about how we combine all of them together. Parts. It's really big long process, and students are meant to be checking on each other. So ideally, each section you need to define which student did it, which other students have checked it, and when. So we need to see. We need you to show all that. That's why in other ways you can consider it to be an individual effort. But in the end of the day, the mark that will be given, if all the team members were happy in that work and it was proven to be done by all team members equivalently or equally, then your mark will be applied for all the team members. Okay. Then you got the final exam. All right, dynamic fundamentals. So as I said, from week 3 all the way to week 11, there are some fundamental skills that a practicing engineer would need to know about to really know how to deal with dynamic problems. All right, so we're not talking about a knowledge skills you need to know to answer physics questions. We won't be asking you, we will take you from that point just to connect your understanding, but we won't be teaching you vibrations to answer a textbook question about like what's the natural period, what's the velocity, what's the acceleration. These questions you may have been done before, but this one we will typically be solving a real world problem, and you're going to see how those equations and theories are helping us to get there. So week 1, right? We're talking about week 1, which is an introduction to dynamics, and which we talked about, and that's where I'm taking you to. And all those skills again will be kind of applied and started implementing from week 3. So, and that's what we're doing in our introduction. So one of the main things you need to understand that systems can be simplified as single degree of freedom system or multi-degree of freedom system. In week 3, as I said, when we start the theories, we will slowly talk about these information. So if technically you're not really on top of what we're talking about, you can still ask, but don't get 100% worried about this because we will revisit all these kind of information. So in week 3, we will slowly let you understand how you can distinguish between a single degree of freedom system, which it's SDFS. SDFS means it's a single degree of freedom system, and there are many structures where it can be acceptably simplified as single degree of freedom system, which is in math or by simplified sketches, it will look like this. So basically, we have one mass to represent the weight of the building. We have one stiffness to represent whatever resisting the load or presenting the stiffness. And there is one application. So that mass is actually getting displaced or vibrated or speeding, you know, at that mass. All right. When you are successfully able to simplify your model like this, then you can call it as a single degree of freedom system. And this is applicable for a structure like this, for a single story building, for a pergola, for a car park, right? Sometimes we have a car park with one level and then a lightweight roof. Yeah, we can simplify it as a single degree of freedom system. There are ways which we also be applying for our first assignment to simplify even buildings as a single degree of freedom system, but they're going to be simplification there. Okay, the other system is MDFS. MDFS, which is multi-degree of freedom system, and it's anything goes above 1, 2, 3, and above. All right, someone will look at it and say it depends on the floors. Yeah, that's almost correct. If you've got 10-story buildings, then you have 10 degrees of freedom system. What does it mean really? It means that how many masses can independently move when you are shaking the building. Right, so when we have 10 stories or 3 or 2, then if we shake this building by a quake or if we hit it by the wind, you know, if we disturb it, if we want to vibrate it, then you can say that we have multiple floors which each got its own lumped mass to go wherever it's like, to freely vibrate. That really defines how many degrees you have. So who defines how many degrees of freedom you got on a system is how many lumped masses can be considered to freely vibrate when you shake the whole structure. This one, it's obviously if it's under a ground motion or wind load, you will have one decent lumped mass to freely go left and right. Okay, so yes, we can say it's single degree of freedom system. If you have a system like this, you know the buildings, they are made of heavy floors. This building obviously has got concrete floors each level, and then each floor is actually can be considered as a lumped mass, and then it's freely to move. So that's simply how can we have single and how can we have multi degree of freedom. One important message you need to understand, and I'll say it now. From week 3, right, all the way to week 9, we basically going to be talking about single degree of freedom system. The methods I'm teaching you and showing you how we're using it in the real world, how to assess the dynamic properties of existing building, how to evaluate the impact on a vehicle when it goes through a speed bump, right? They are all single degree of freedom systems, okay? And we're teaching you deeply those skills based on single degree of freedom system. Then what's going to happen when multi-degree? It's really going to be, the concept is simple, but the process of doing it, it's longer. Right, it's just the same concept. You're just going to need to repeat the process over 2 masses if it was 2 degrees, 3 masses if it was 3 degrees, 10 masses if it was 10 degrees of freedom. The concept is simple, same, but mathematically what we use to do that, we use matrix. That's where it's just going to be, you know, when we do matrices, it was easy to do by hand when we have 3 by 3 or 2 by 2 matrix, but when it goes to 10 by 10 by hand, it's difficult. That's why we use what softwares, and engineers going to use what like the one we're going to be talking about next week. Okay, so my message here was telling you we're going to teach you a lot of real world application skills as a single degree of freedom, and that's what engineers do outside. Yeah, when you have a bridge and they want to assess its structural situation. They apply impact tests or free vibration tests, which basically is coming from what? Single degree of freedom methods, which I will let you apply and practice. So that's my key message about these topics. This slide is again talking to you about single degree of freedom systems, which summarizes what I was talking about. It is considering there is one mass to deal with, and if you are successfully able to say that structure can be lumped as one mass and the vibration is resisted by one stiffness, then it's a single degree of freedom system. And these are the examples we talked about. And again, it's clarifies this paragraph here is talking about when you are able to have a lumped mass or concentrated mass in your system. So again, if you have here a single story building or a pergola, now this floor is stiff enough so you can actually represent it in a mass, in a one lumped mass. And obviously when it's going to be under motion, it's going to be imposed on that mass, right? And the stiffness going to be here coming from two columns. Yeah, we have here two columns for your stiffness, but you can simplify this by one single K like this. So this is also doable. So degrees of freedom, as I said, it's coming from the number of masses that represent the buildings, not the number of stiffnesses. Okay. And I will be redefining this for you when we start talking about these things in week 3. So what we're saying to you, sometimes your system. So let's talk about the properties here. We do have a mass, we do have motion, right? We do have stiffness. In some buildings, we have dampers. Dampers, we will talk about it slowly in one of the topics or weeks. And you will know about it. Dampers helps to absorb the shock, like what you have in your vehicle, the suspension system. And sometimes we need to have it in buildings. And it's up to the engineer if he wants to put it in the system or not. So in case we have it, we also can have it for a single degree of freedom system. All right, we're talking about this here as the FS to include damping components if exists on the modeling structures. We will also have weeks talking about this as we're gonna see. So dynamic behavior of a single degree of freedom system will be covered in weeks 2 to 8. As I've just briefed you already. Is it 2 to 8 or more? Yeah, well, we're saying 2 to 8. It's actually 3 to 9. To be more accurate, it's 3 to 9. Yeah, so it's going to be spread over a couple of weeks. And then those skills can be expanded over more and more. Not just to let you know, don't get confused. Where is the multi? Because maybe we go over the weeks and you still don't know when. Why we're not talking yet about multi? We're already learning the skills. Then at the end, we're going to show you how you deal with multi-degree of freedom system. And remember, you're already doing it with your software, but we're going to talk about theories. So this slide is talking in detail about the multi-degree of freedom system, which I've already briefed you about. Here, simply, you're going to be having two, like if we're talking about 2 degree of freedom system, you have 2 masses that can model the motion of the building. And what does it mean? Each mass can independently move when we shake this whole building. So you can have a case where this floor goes to the left, or sorry, to the right, and this floor here or roof can go to the left, right? We will talk about these kind of issues later. And as I said, it's going to be in week 10 and 11 for the multi-degree of freedom systems, right? It's independent. There is no link between this floor and that floor. This floor can go to the left or right, and this floor may go together with the with the one above or can go in the opposite direction. It's got its own freedom. And this is the pure definition for degrees of freedom. That's why they call it a freedom. It's how free the floor to go, or how many freely masses we got in a system. Okay, so simply in buildings, it is the number of floors. That's it. And a single degree of freedom, if it was obvious, it is applicable. Okay, so same thing as we said here, the dynamic behavior of multi-degree of freedom system will be covered in the last, so it's week 10 and 11. These are correct. Yeah, 10 and 11 will be talking about multi-degree of freedom system as summarized to you here as well in the table. Okay. Right, so that was one of the main topics we will be talking about in week. Let me go back to the table just to clarify. So that was equation of motion, week 3. We'll be talking about equation of motion for a single degree of freedom system. That's during week 3. So when we start talking about those free vibrations, we will take you all the way back to the equations of motions, because you're going to see they are representing the parameters, like representing the mass, representing the stiffness, representing the damping if it exists, representing the motion, representing the external force if there was external force. So this is another skills we're going to be talking about that will help us to build skills for the coming weeks as well. So we're going to let you sense the difference between free vibration and forced vibration. Free vibration, let me talk about it practically. For example, if you have an old existing structure that the council likes keeping, and they each year or every 6 months they want to check its situation, or maybe after an earthquake or heavy storm, they want to check its health and its performance. So what we do free vibration tests. What engineers do there, they try to connect the structure, maybe here or wherever it's practical. They will try to connect the structure with a cable and pull it this way, maybe for 20 millimeters or 30 millimeters, 2 or 3 centimeters. Then they're going to pull it aside, yeah, and then they're going to release it to vibrate. We call this as a free vibration system, free. So we kind of pre-disturb the system, then let it freely vibrate. Because some people, when they're going to look at this, they're going to say, we're talking here about earthquake and wind load, so we always have a force. All right, so if I go back to this double degree of freedom system, someone will tell me there is a P. You showed us there is a P. P means it's external force. That's when we have an earthquake pushing the building. If we have a wind load pushing the building, yeah, there is an external force. We call this forced vibration. There is, and especially mechanical engineers got this, with the vehicles and cars and whatever they're studying, they always got a force which causes the vibration. In engineering, as yes, we do have this happening when we have an earthquake hitting the building or wind load. But on the other side, we use free vibration theories where we pre-vibrate things, because it helps us. Now, if I go back to that water tank story, someone will ask me, why are we doing this? Because you're going to do this in a few examples. When we're going to pull the water tank and let it vibrate, we will measure the displacement versus time. That will help us to answer important questions like how stiff is the columns of that water tank, right? That will tell us whether it was damaged, because if it was a newly built building, you can go from whatever you studied at university and work out the stiffness. Okay, but if it's an existing building, maybe there are micro cracks that have been developed or bigger from an earthquake, and you can't do it by hand now. You have to test it. right? So that's why we use free vibration theories. So it's taking me to this point in this slide. We do have structures that are undergoing free vibration. And because sometimes people will say, why we have free vibration? Especially in structure or civil engineering, we do have to test things. And when we test things, we have to freely vibrate things. So we just give it a pre-displacement and let it go. And then we study whatever you study. Remember, one of the other features of the free vibration here, there is no damping. One of the things you need to pay attention is there is no damping, like it keeps vibrating like this forever, which is not true. You can't have structure keep vibrating forever. There is always what? Damping. There is whether internal friction or into like heat or whatever that will, you know, damp down the vibration. Yes, I agree with you. This is, you will never have in this world, yeah, a system which is gonna, unless like a system that will be keep vibrating forever until unless it is a mechanical toy or something that they're gonna make it super smooth or whatever they use, you know, like those small toys or statues which keeps moving forever. And this, you can't have this in a building. Okay, you won't have this in a building. As a civil engineers, your system's gonna always have some damping. Why are we looking to this or studying them? Because it will help us to learn some theories, and then we're gonna go to the real life, like what we're seeing here. Okay, so this is our real life, which we will talk about in one of our weeks as well, slowly. Right, let me go back to the slides. I was just simply comparing between free and force. So you all know what free means. Free means you're gonna pre-disturb the system and let it go. Force vibration, it is an earthquake hitting a building. Okay, it is a wind hitting a building. It is a truck hitting a building. So that's a force vibration. So that's the difference between free and forced vibrations. And I trust there are just simply here notes which will explain to you. Now, there is another topic which I will again, or the subject will take you through. After you're going to learn about free and forced vibration, we want to teach you about harmonic and periodic excitations. Harmonic and periodic excitations. One of the other ways which we can use to test the health and situation, the structural situation for existing buildings, and to be more accurate, instead of, you know, as I said to you just before, one of the methods is to actually pull it and release it. This may be not doable. It's maybe costly, right? Because you may not have the freedom to do that. You may have a building, like in the city, in the CBD, you got one building next to each other, right? How are you going to actually let it free go? Maybe you have a street, you cannot really apply that free vibration approach. You cannot pull the building and let it vibrate. Okay, maybe here, as you can see, this building got buildings around it, got a street in front of it. You can't mechanically do that. You can't. So what's the other option is we apply harmonic motion, and we will have a week talking to you about this. There is systems, right? Like vibration generators, where we can attach a system at the top here, attach it, and that system will actually cause a vibration. That vibration can be set to be harmonic. Harmonic means it is constant vibration. So let me go back to this topic here. Yeah, we're talking here about the difference between harmonic or periodic. Harmonic, it means just a motion. I think we have it here. This is imagine this is like that engine or whatever mechanical component is going to make this harmonic motion, like a sine wave or cosine wave. Let me make it simple for you. Harmonic motion means you're applying a sine or cosine wave on your structure. We will talk about this slowly over the weeks, and we're going to do examples, and we're going to talk about real problems. So these are the skills I'm talking about. Okay. Sometimes we like to, what we're going to apply in this subject is mostly or 100% harmonic. Harmonic means it is, as I said, sine wave or cosine wave, some like vibrations like this, which goes forever. It's like a forced vibration that we're going to put on our structure. Okay. Periodic means it will change. We're going to be like this, then goes down like this or go up. So it's going to be changing over time. And in civil engineering or structural engineering, we don't use these profiles. They use it maybe in other mechanical components, like when they design vehicles, but not for in civil engineering. Usually, all our studies we use harmonic, a sine or cosine function. Okay. Now, practically how these are generated, we will talk about this. There are special equipments we attach inside the floors, and we let it do this kind of. Why are we doing this? We don't want to break the building. And remember, engineers, they have to be super careful. They don't overkill the buildings. They have to set it in a way where it's going to impose acceptable vibrations. They can't do it too high, because we don't need to crack the structures. We do it below the limits, acceptable limits. So then, again, people will ask, why are we doing this? Because those kind of, after we impose the harmonic vibrations, we will be recording as well to see how the building is performing for such vibrations. And then those results will help us to answer many questions, many important questions, which will be sort of the questions you're going to be asked in your examples. Okay. So I think up to this now, I did talk to you about the difference between a free vibration and forced vibration. I talked to you about harmonic motions and periodic motion, harmonic and periodic motions. And I think one of the things I talked to you about, sometimes building, we can apply on them free vibrations, sometimes we can't. So then we're going to use harmonic or periodic excitations. Mostly or 100% we're going to be using harmonic. Now, you're going to be learning what's the difference between damped and undamped. I think most of you, if they studied, I know some courses, they don't heavily study dynamics. Some of them do at undergraduate level, but undamped and damped, in real world, everything is damped, especially in civil engineering, as I said to you. But we're starting talk to you about undamped because it will help us to teach you the basic properties. It's going to be too difficult. And then we will talk about, like, this curve here shows you the response of a building when there is no damping. So again, because it's starting with a displacement, that means it was freely vibrating. It's starting with a disruption, and that disruption caused some momentum. So after that, it is, you can see it's vibrating. What does it mean? This is your single story building. At A, it is going back to 0. So it's kind of not going to the left, not going to the right. Then when it comes to B, it's going to the amplitude here, which is going so as much as it can to the right. Then when it comes back to C, it's going back to the stable condition, and so on. So why we are looking at undamped, because it will help us to understand the dynamic properties. Then we will study and talk about damped vibration, which is the situations we live in the real world. And you're gonna, from theories, we will, again, you don't need to 100% get on top of those skills, because I'm just letting you get ready and see what we're going to go through from week 3 forward. So when we get into the damped systems or damped vibrations, you will learn that they can come up with 3 forms. The undamped vibration, the damped vibration systems can come in 3 forms, which actually we'll talk about in the next slide. So let me We are not showing them here for you. Maybe yes, maybe no. Yeah, we have them here. That's all good. So yeah, simply this picture or this image or this plot is showing you the difference between undamped structure and damped structure. So obviously the undamped, which is not real, is just a system which goes forever with full amplitude, but this is not possible. You can't have a system shaking forever, especially in civil engineering. It's gonna stop at some stage. As our engineers, this subject will teach you how to make sure those amplitudes, which are displacements or speed or velocity or acceleration, will not go to you beyond the limit, because you may break the building. So we're gonna go through all those theories and see their practical applications. Damped, yeah, as you know, and as we're gonna talk to you in maybe week 4 or 5, damping, even in buildings where there is no, you know, in like in high seismic regions like Japan or the States, they have special cylinders which act as a dampers, like what they have in the cars. We don't have this in moderate seismic region. However, someone will say that means we don't have damping. No, we have damping. Also comes from the friction. You know, it can come friction between the material itself, the particles of the material itself, like concrete or steel, and the frictions or damping mechanisms we have at the connections between the beams and columns, beams and slabs, columns and footings. These connections got some sort of damping, you know. So there is a damping. Now, how to measure that? You can see someone will say, oh, this is too complicated to measure. Well, that's why we use tests. That's why we use tests. Tests can help us to give us those figures, and these kind of the knowledge and skills you're gonna be practicing in this subject. Okay, so again, from this slide, I'm simply just trying to let you know there is systems, dynamic systems known to be undamped, dynamic systems known to be damped, and you will learn more and more about them. Now, when you know that your system is damped, as I said, in the real world, they are all damped. You need to know that there are 3 types of damped systems. One of them is called critical damped, the other one is over damped, the third one is under damped. Now, I think that's enough for you to know today, but over the weeks, you're gonna know what's happening here, okay? And you know, as a quick message from here, usually what we practice in buildings, this is the situation we're gonna be in. Our systems usually shake, and then over time, it's gonna get the amplitude gonna get reduced and go to 0. These 2 systems I'm showing you here, they're not really applicable for buildings, right? Maybe for those speed and situations we try to think about them, but again, they're not 100% there. What does it mean? I mean, we're going to talk about them slowly later over the weeks, but this means when you are pre-vibrating a system, it will go straight away to 0. You know, that's what mechanical engineers want to design when a car hits another car. They would like to create a damping system that will suck all the energy, because that's their aim. They don't want to let the cars to bounce back to another car and make a damage, right? So usually these systems are not achievable by civil structure engineers, because you cannot do this for the buildings. Can someone tell me why? Can someone from the group tell me why? Now, what I'm telling you, these curves, whether they're critical damped or over damped, I'm just zooming in there, whether critically damped or over damped, they're giving us this behavior. Practically, what this behavior means is after we apply a displacement or acceleration or a shock onto a structure, in one go, it's gonna get damped to 0. So we're gonna suck the whole impact, and then everything goes back to stable, right? The third curve, undamped, it's no showing us there's gonna be some kind of vibration until the energy dissipates and the amplitude dissipates and goes back to zero. I'm telling you now, it is not possible for structural engineers to design buildings with this. Can someone tell me why? With these first two profiles. Or let's say I would like to do it that way. I would like my building, when it's hit by wind or earthquake, it's gonna straight away go to zero. What you will need to do to get this done? Any thoughts? Yeah, we all know that buildings are flexible, and if you really want to get such things, you won't have reasonable sizes of columns or reasonable sizes of beams or shear walls. They're gonna be huge, right? It's just not feasible to have, by theory and equations. Yes, you may end up finding a way to make your response to be like this, where it's gonna go in one in one go, it will get the energy gonna get dissipated. But if you want to get your building to be like that 10-story building you're gonna be working on from your workshop this week, this means your column's gonna be maybe 5 meters by 5 meters, which is not possible. You may not be able to have windows in your building because all that gonna add. No, you can't. It's just not feasible. Okay, so that's the reason typically in civil engineering, buildings gonna need to vibrate before they get. So we're gonna go through these skills slowly. Now, after we finish with damped and undamped, we're gonna have a topic talking about pulses, like wind hitting a building or a truck hitting a building, and you're gonna see that it depends on the shape of the pulse. We will take you all through that and start seeing. You're going to see some of the topics got really very complicated equations. You just don't need to worry a lot because this subject is not meant to teach you or ask for your mathematical skills. I'm just showing you the background, and then we're going to take you all the way to the simplified check or formula to use or approach to use, and that's what you're going to be asked to do, which you will be experiencing over your worked examples and workshop questions. Okay, which is a good learning curve. So when we're going to be talking about pulses hitting a building or a structure, as you're going to see, we're going to take you through different shapes of pulses, and you're going to distinguish the differences between each and how the building is behavior and what does it mean if we have a rectangular pulse or half sine pulse or a triangular pulse. You're going to see how the building will be responding to each type. Now, when it comes to the engineer decision, which one he should use, it really depends on the problem. Are we worried about wind load? Wind can be modeled something like this, because wind, when it comes and hits, it's gonna be applied for a few seconds. Remember here that this is the time, right? And here we're talking about very small fraction of a second, maybe half a second, maybe 0.7 of a second, right? And when wind hits a building, it maybe can stay for 1 second, like pushing it. So that will be used for maybe modeling the wind load on the building or a single degree of freedom system. This one can be applied for different cases, like the speed bump situation I'm talking about. This one can be more sharp. It's really up to the designer to choose. You know, in our questions, you're going to be asked to use one of them and solve problems. So yeah, so far that was about pulses. Now, after we finish with pulse, we're going to get more into, again, another thing which is really important for you guys to know. Here we're going to have non-harmonic said to you harmonic was something like a sine curve or cosine. But again, someone will tell me in reality, earthquakes, they come like this all over the place. Very randomized. Yes, that's totally right. That's why we're going to study in one of our weeks. So non-harmonic or periodic motions, we will be teaching you how engineers deals with these motions and the methods used to, so remember our aim always is to find building response, right? What does it mean? Is to calculate what the displacement the building was moved with, or acceleration or velocity, one of them or a few of them. That's the final question we always after. If you hit it with a pulse, what's going to happen? If you hit it with a harmonic, what's going to happen? If you hit it with a free vibration, what's going to happen? That's simply what we're doing. And then we're taking you to the most complicated case, which is you hitting it with the randomized vibration. And El Centro is one of the famous ones, happened in the past in the States. And there is also, so I'm showing you here an example of ground motions, how to deal with this. Now, when I was talking to you about harmonic, obviously someone will tell me we're going to use the sine equation or formula and stick it inside the equations and build all those things, correct? With this one, is there any equation to tell us about this? No, there can't be a closed form equation. There's no equation which can represent this vibration. So what do we use? What we use, numerical time stepping methods. Okay. And this are, some of you have made, this is a math topic. Some of you have used it, some of you did not, some of you forgot it, which is all fine. So we'll take you through that. There is a time stepping, and from here, guys, that will be the start of your assignment 2. So assignment 1, maybe all the skills we've been using, in part, the skills that we've been talking about here may be used for answering assignment 1. Assignment 2 will start from here. I will be giving you a real earthquake motions, and I will ask you to do something about it. And then I will ask you to do some checks about your building as well. So, which is really a good knowledge and good to really practice such things. It's a high chance to be used in your engineering applications. So, and yeah, that's will be done. As I said, most of what you've been studying is going to be for a single degree of freedom system. Okay. When we are done with single degree of freedom system, we have 2 weeks to talk to you about how things needs to be readjusted or reconsidered or reused when we will be dealing with multiple degree of freedom system. Okay. And our exercises will be about 2 degree of freedom system. We won't be using more than this because it's just going to be all about time you need, right? So that's really, we're going to have week, as we said, 10 and 11 talking about multi-degree of freedom systems and earthquake response to spectrum. Yes, this is one of the things we're actually going to apply in our second assignment as well. Spectrum analysis, it's kind of summarized in this page, and we're going to slowly talk about this in one of the weeks. This is actually happening before we start multi-degree of freedom system. So, you know, after we teach you how to deal with earthquakes here, after I teach you how to deal and use numerical analysis to deal with those non-harmonic motions, I will show you how to plot what we call it spectra, response spectra curves. It's very, very important. These curves kind of a guideline for you and other engineers to use to assess buildings. The usefulness of this building is, I'm going to end up asking you plotting many of these curves in your second assignment. You're going to submit almost by the end of the semester. How it's used, simply, you know, you're going to go using first principles, which we're going to teach you to find the time period of your building. Somehow, you're going to find the time period, natural time period of the building. If you know this, right? And if you are worried about an earthquake in Melbourne, earthquake in the States, somewhere else, whatever, in New South Wales, there is a spectral curves that I will teach you how to develop for those regions. And then by the time you developed that spectral curve, you simply then can use it. As I said, by knowing the natural period, you can just plot on your, if you have it 1.5, for example, you plot it here, then this will give you the anticipated displacement from the excitation. So what the spectral curves show you, it kind of give you a representation for displacement. The one we're seeing here, remember these spectral curves can be done for displacement or velocity or acceleration, but this is just an example because here we're just introducing it to you. So it will tell you, give you a quick snapshot about what displacement is expected your building to have if it was meant to be built in Brisbane. So if you have a building, 20-story building to be built in Brisbane, then from day one with your engineering team, go and work out the natural period, okay? And then go do long analysis to develop such curves. It can be different curves for different regions, obviously. Then after you do that, you come here and that 20-story building in Brisbane, you come and find its natural period. If it was coming maybe 1.3, then put it here. Then try to, once it's hit the right curve, which depends on the region and other properties, then you can estimate what your estimated displacement. After you know displacement, you will work out whether this building will be able by its own to absorb such displacement. Okay, and this is the story. So in a quick scan, it looks really that, you know, always when you study with me the subject, make sure you know what's the aim. Right? Don't get stuck about calculations and you don't know really. And that's what weakens the students a lot, is they don't know what they're doing, which is a problem with engineers. If you don't know what you're doing, you will be doing calculations, but you may go in the wrong path. And this is where weak students really, when we ask them questions, they go and find things we're not asking you to do, or maybe they have it in the question already, why they're calculating it. And definitely people who are going to be practicing on time, they will just be on top of the skills. And, you know, if you practice things slowly, it's gonna stay longer in your mind and in your, you know, easy coming, easy going. So if you study something quick, which, as I said, you don't need to study these topics 1 week or 2 weeks before your exam, because if you get things quickly, you will forget it quickly. This is our introduction. And maybe from now until Wednesday, can you look? I think this has changed. I know it's face-to-face, but people who may be practicing, try to download and use this code. If it does not work, we will find ways to get it to work. This is that software I was talking to you about. But remember, there's another software for you to use. Okay, one of the methods to use the software is to have it on your computer. There is another way to use the ones in the lab, in our computer labs, and there is also a way to use our virtual access point. So we'll work on these things and we'll find a way to let you use whichever. So we'll talk about downloading the software, accessing the standards during the workshop. But if you want to give it a go, and send me email if it's not working with you, because it may need to be updated. The supplier may update his links. Okay, that was our first lecture, and let me now just, do you have any questions? Okay, so some people are saying it's not working, but I will ask for the update, no problems. So Anouk, did you download it, and did the software download? But did you download it? Did you download the software? Yes, okay. So yeah, it did download, you just need the new code. No problems. All right, you should have an updated one. Any other questions? Okay, let me stop recording for now. And